Are you interested in more amazing videos? Just log into www.amazeworld.tk and have fun.
You may not know this, but you can create amazing scientific experiments using things you find everywhere, everyday objects. Now, Dave Ansell from the Cambridge Science Festival is an expert at this. And from his garage-based laboratory, we find out how he gets his ideas and how he makes them work.
Okay, here's a piece of kit I built a couple of years ago to explain why we have one of our more unpleasant fluids, ones which people aren't very keen on. It's why we have snot. So what we have here is a giant papier-mâché pink nose, which I feel is always a good start. And in it we have two nostrils. And attached to those nostrils, through these pipes up here, we have some giant lungs. Now, lungs for a nose this size would be about the size of this garage, and moving those around is quite difficult. So I've used hoovers, which are pretty much as powerful and pretty good as well. Inside your nostrils, you've got nose hair. And I'm modelling that nose hair using these nice pan scourers here. And now what I'm going to end up doing is putting snot on one pan scourer and not on the other, getting it to inhale some dust and soot. I've got some crushed charcoal here to be like all the dust and soot which you get just breathing in the air on a normal day in London, for example. And I'm going to get it to inhale through the two nostrils, and hopefully you should be able to see on these bits of gaffer tape difference between snot and no snot. So here's some snot which I made earlier. It's actually been quite difficult to deal with. I'm going to put this snot on this nostril here. Just get it really well covered in snot. Right, so I now have a beautifully snotted nose hair. Well, might make my life easier. After all, to compare it to, we're just going to put the nose hair straight up. Okay, right, so now we're going to start off with a nostril with just nose hair. And turn on the hoover. We're going to inhale some of the dust and see how much gets sucked straight through into your lungs. Right, so we'll move this in here. Okay, so as you can see, there's been lots of dust and muck, and especially the fine dust has been sucked into that nostril, into your lungs, which would not be very good for you at all. So now we'll try the nostril with the snot in it. So power it up. Going to inhale some. And now they've both inhaled about the same amount of dust. So if you look at this tape here, it's virtually pristine. So none of the fine dust has got into this lung, through the snot. Whereas when you didn't have any snot, there's lots and lots of fine dust covering this piece of tape. So it's gone deep into your lungs, and it would gum them up. It might have got them infected. It might have just poisoned you. And so snot keeps your lungs nice and clean and healthy. I've been having a look at some stuff with static electricity, which hopefully I should be able to get a nice experiment running for the Science Festival in a few weeks' time. So, for example, I've got a balloon here, which I can charge up. For reasons I don't understand, if I do it on my hair, my head hair, it never actually charges up. But something I've noticed is that when I charge it up on my leg hair, it works a lot better. So, excuse me. So what's happening here is that static charge on the balloon is attracting the polystyrene balls. The Earth is a great big thing which conducts electricity quite well, and you can add a little bit more charge to it or take it away and it doesn't really notice. So it tends to stay at about the same voltage all the time. So what I want to do is take this little piece of foil, charge up the balloon, then hold the foil near it. All the negative electrons then move to the tip of the foil because they're attracted to the balloon. If you take it down into little polystyrene beads, it won't pick any up because the electrons have spread themselves back evenly across the foil. So when I hold it up over the beads, there's no charge, so there's no attraction. However, if we attach the foil to Earth using this wire and hold it near the balloon, all the negative electrons come up the wire from the Earth and are attracted to the positively charged balloon. So that when I unattach the wire, the foil is still strongly charged because it's full of these negative electrons.
Are you interested in
And they
more
can't escape
amazing
back to Earth.
videos? Just log into
And this time, when I hold it near the polyethylene balls, it picks up
www.amazeworld.tk
lots of
and
them
have fun.
because all the negative electrons in it.